Hello students, today we are going to discuss the next part of the chapter gravitation. I have already discussed starting topics of gravitation in the first video of this chapter. If you have not seen that, then I'll provide you the link of that video in the end. Students, in this video, first we will talk about importance of gravitation or the law of gravitation, which is given by the great scientist Isaac Newton. Due to gravitation, only the existence of each and everything is possible on the earth. If we are stable on the surface of this planet just due to the force of gravity, so it binds us to the earth. Due to the gravitational force, the moon revolves around the earth, otherwise, it could have gone anywhere. If all the planets are revolving around the sun, that is just because of the gravitational force. Even the tide which comes in seas on the earth is due to the gravitational force which is applied by the moon on the water. Now, if we think that the gravitational force works between all the objects, then why can't we observe? So, it depends upon the magnitude of gravitational force. We try to find out the gravitational force between two small objects. Now, let us consider two objects. The mass of the one object is 500 kilogram and the mass of the another object is 10 kilogram. Now, as per the formula, we know that force of gravitation F equals to G into M by R square. Let's say that the distance between these two objects is 1 meter. Now we know the value of capital G, that is 6.67 into 10 to the power minus 11. Now we put the values of the mass of the two objects and the value of R. So 10 into 500 divided by 1 square, that is equal to 1. Once we simplify, we get F equals to 3.335 into 10 to the power minus 7 Newton. As we can see, the magnitude of force between two small objects is very less, or we can say almost zero. That's why we cannot observe it. But when we release any object, we observe that it comes back to the Earth's surface. It means the Earth applies an attractive force and we observe it easily. So let's find out what is the magnitude of force between Earth and any object. Mass of the Earth, we know that 6 into 10 to the power 24 kilogram. Let's say that we have an object, the mass of that object is 10 kilogram. If the object is kept on the Earth's surface, so the radius of the Earth will be the distance between the centers of Earth and the object. So by formula we know that F equals to G into M by R square. We put the value of capital G, the mass of Earth and mass of the object. So finally what we get? We get F equals to 98 Newton. Since 98 Newton is an observable amount of force, that's why we observe it easily. Dear students, now we talk about Kepler's laws of planetary motion. Johannes Kepler was very much interested in getting the knowledge about the planets. So he observed the motion of planets and he proposed three laws which basically deals the motion of planets around the sun. Kepler's first law says that all the planet moves in an elliptical orbit where orbit is an imaginary line with the sun being one focus of the ellipse. Students, as we try to understand what is ellipse, so ellipse is also a geometrical figure like square, circle, parabola, which has two focus. You can see F1 and F2 are two focus, and the straight horizontal line is called major axis. So AB is a major axis, and vertical line is called minor axis. So CD is minor axis. O is the midpoint of AB and CD. So Sun is present at F1 and all planets move in the path which has elliptical shape. So this law is called law of ellipses as well. Now we discuss about the Kepler's second law. According to this law, a planet sweeps out equal areas in equal interval of time at the different positions on the orbit with the sun. For example, if the Earth moves from point G to H on orbit in t time interval, then the area which comes under the region G, H and Sun will be same if the Earth makes the area between E, F and the Sun in the same interval of time t. So let's say if in first condition the area is y and in second condition the area is x. So x equals to y where time period is same. Kepler's second law deals with the change in speed of a planet. When the planet is near to the sun, the gravitational pull is high. Due to that, the speed of the planet is fastest, and when the planet is far from the sun, due to long distance between sun and the planet, the gravitational pull is weak, so the speed of the planet is slowest. Now we talk about Kepler's third law. Kepler's third law basically informs us about the relation between orbital period of planet and its distance from the sun. If the radius of the elliptical path increases, then the time period to orbit the sun also increases. So, if r is the semi-major axis and t is orbital time period, so we can write r cubed is directly proportional to t square. For removing the proportionality sign, we introduce a constant k that is known as Kepler's constant. Since this relation is based on a condition, so this law is also called law of harmonies. So students, I believe that you all have understood these points clearly. If you have not subscribed the Alam Academy, do it right now and get the access of all the educational videos. Thank you very much for watching this video. Bye.